So question 15 says convert the measure to degrees, then convert to radians. So what they want us to do is convert the 54 minutes into degrees so we have it all in degrees. So remember, there's 1 degree, there's 60 minutes. If we have 1 minute, there's 60 seconds. And if we also have 1 degree, there's 3,600 seconds there. So it looks like all we have to do is convert minutes to degrees. So 54 minutes, if you will. If we multiply by the conversion factor, since we want degrees, we want the 1 degree on the top, and there's going to be 60 minutes on the bottom. So what we're converting to goes on the top, so the minutes is going to divide out. So basically, this is going to be 54 divided by 60. So 54 divided by 60 gives us then 0.9. So this turns into 0.9 degrees, if you will. So if I had the 88 degrees, the 0.9 degrees, this turns into 88.9 degrees. So it's set around to 4 decimal places, but like I said, we're only going to have the tenths place because it didn't go out that far. So from there, let me see how they want to convert here. Hold on a second. So when it comes to turning it into radians, they do want us to now round to the nearest hundredth. So what we have is the 88.9 degrees, and now we want to round that to the nearest hundredth, is what essentially they want us to do here. 88.9 degrees. So remember, our conversion factor is for every pi radians, there's 180 degrees. So if we have 88.9 degrees, if we're converting radians, the radians got to be on the top, so the pi's got to be on the top. So it's pi radians, if you will. And 180 degrees is going to be on the bottom. So this basically tells me then to multiply 88.9 times then this pi over 180. Notice how the degrees will actually cancel out of the problem. So that just leaves me the radians, which we can just leave out for the time being. So 88.9, if we then multiply that by pi divided by 180, that'll convert that into radians. So 1.55. Now remember, 90 degrees was 1.57 radians, so 88.9 degrees should be really close to that. So they say round this to the nearest hundredth, so 1.55 radians would be our result. So remember, a radian, a lot of times uses this Greek letter theta, represents the arc length divided by the radius. So that's how radians are measured, is the arc length divided by the radius. And that's where this number 1.55 is generated from. Now, if I use the calculator, I could type in 88 degrees, 54 minutes. So 88 degrees, 54 minutes. And then if I hit enter, it'll turn into degrees, 88.9 degrees. Now, if I type the 88.9 in, if I hit degrees and hit enter, it should then turn it to radians because the mode in the calculator is in radians. So it understands that this is going to now get turned into radians. Now, notice that if your mode is not correct there, if it was in degree mode, let's see what happens if it was in degree mode. So 88.9 degrees. If I hit enter, notice it just leaves it in degrees. So it is important to convert degrees to radians to make sure your mode on your calculator is in the correct mode. So that's one of the ways that I'm familiar with doing it. So then it should work out from there. So at 1.55 sounds reasonable because we kind of knew that 1.57 radians is 90 degrees. So it kind of checks out using estimation.